Hello and welcome to TidyX episode 149. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name is Patrick Ward. Thanks for checking in with TidyX. We always appreciate having you here. As a reminder, like and subscribe on that YouTube channel. Drop questions and comments down below, and your ideas and thoughts may become an episode in the future. Also, we love doing the show, and if you feel like we've positively impacted you in some way, we do have a Patreon page. We're always grateful for anything that you may give. That being said, we're going to jump into TidyX episode 149. We
Let's
did
do it.
148 as sort of a fun little, hey, let's use Shiny and show people how they can allow their users to build models. And probably much to our surprise, we did think it was a fun episode, but much to our surprise, it was wildly popular. And
Yeah, y'all are
we got a lot
amazing.
of great feedback. We got a lot of great questions about extending it and options for different model types and things like that. So we're working through that, and we're gonna do it. We're gonna keep extending this over the next few episodes. So this is the first extension of it, and as you can see, Alice has pulled up the Shiny app that we built for this week. We've taken what we did last week, which basically just fit a model to whatever outcome and predictor variables the user selected to fit a linear model. This week, we've added the option to specify your training and test set split. And so that's done with the slider bar, which is allocating a percentage of training test split. So if we add some data here, what you're going to see is, so for example, we've got an outcome variable of MPG. You can see that the data is, the model has built something. It has no variables in it yet. So we're going to put some predictor variables in. And lo and behold, we get a model, and that model then gets, we can see at the top of the page the fit of that model with the training set. And then below that, unlike last week where we used all the data, this week, all we're doing is we're plotting the out of sample performance of this model. So we have the out of sample mean absolute error and the residuals plotted below, which I think we'll have to remember to put on the x-axis residuals so that we know what that is. We'll do that when we go through the model. And then on the right, we've got the predicted values relative to the actual values with a line of equality. That's a line with an intercept of 0 and a slope of 1. And that's on the out of sample values as well. So we basically built the model, and we're showing what that model looks like on the training set up above. And then below that, we've got how that model performs on the out of sample data on that test set. And then just for a sanity check, we've also allowed the, there's the option to change the amount of data that you utilize within the training set and the testing set. We're going to show you what that looks like within the server of this and how it gets randomly allocated. We've also added some tabs so that now the user, once they fit their model, can see, well, what data was contained in my training set and what data was contained in my test set. And you'll see that right now we have a lot of data allocated to the training set. So that test set only had, I think, 4 observations.
Yep.
So if Ellis drops the training set data down, we're going to get a whole bunch more data allocated to the testings. So that's a little overview of what this the end product looks like. Let's jump into the nuts and bolts of how we got there, particularly the things that are new, because there's going to be some stuff in here that we did last week that's sort of constant. Yeah.
Yep. And we'll zip over those. We'll touch on them a little bit just to make sure, like if you're just joining for the first time, you'll know what's going on, but definitely go watch episode 148. And that's where we go into detail on these things.
Yep.
So the first things we got going on here is we've got 3 libraries that we're going to be using: Tidyverse, Shiny, and DT. Just load them with the library call there. So we've got those locked and loaded. Next thing we have our theming that we're going to be setting. This is just so that we don't have to go through and set our theming for every individual plot in our Shiny app. We just set it up here once and it's good to go. So we run that. All right, great. Now we've got our UI. So the UI here hasn't changed all that much from last week. So it's a fluid page, and that defines the high level page of the Shiny app. And we like to set things up with a sidebar and a main panel. The reason being is that way you have all the controls in the left side and the sidebar panel, and then you have all our outputs in the main panel on the right hand side. So we define that left hand side with the sidebar panel function. We have the file input, which is where you upload the data. Here we set the input ID to be file. We have these 2 select inputs, and that defines the yvar and the xvar. So the continuous outcome variable, so that was MPG in the empty cars data set we just looked at. and xvars. And so by default, both of those start out blank because we don't actually know the data that's been uploaded, but these get populated after the data gets uploaded into the Shiny app. So that's why, excuse me, choices is this empty string here. And then because xvars has multiple entries, we set multiple to be true. And then the new piece for this week is the slider input. And the slider input is what's going to define what percentage of the data set that gets uploaded gets split into the training set and the testing set. And by default, we set, or excuse me, the input ID is called train set. So whenever we want to reference this in our server, it's going to be input $train set. The value, so the default value it's going to start with is at 0.75. So 3/4 is going to training, 1/4 to testing. The minimum amount that you can set your split to be is 0. So that means no data goes into training, all of it goes into testing, which is, kind of silly, but you got to set it up for the app that way. Maximum is 1, again, meaning 100% of the data goes into the train set, nothing into the test set. And then we set the step to be 0.05. So you can only select in increments of 0.05. Then we go into our main panel, which is the right-hand side of our Shiny app here. We set up the tabs using the tab set panel function, and then we have the input ID called datasets. And so then we have our 3 tab panels, which define the 3 views or 3 tabs that we have there. The first one is the model results. So the title is model results. We have our verbatim text output to show our model output, and a fluid row, a couple line breaks there, and then a fluid row to plot those 2 residual and prediction plots that we had next to each other. And then we have our second tab panel, which had the training table. It's a DT output, and the test table, that's also a DT output. That way we can kind of visually split them and make it a little bit easier, because we don't want to overload, right, our viewer of the app with all the information all at once. Using these tab panels allows us to go, okay, here's the information we think you want to see first, and then if you want to dive into it, there's more tabs later on for you to explore more if you'd like. And so that's a quick touch on the UI. Patrick, what's going on the server?
All right, the server starts out exactly the same way. So if you wanted to remember it as a function, it takes an input output, and then we use session because we're going to be writing things back to the UI, like column names once the data is uploaded. If you really want the overview, the deep dive on how this worked, episode 148, we dedicate to just that. But in a nutshell, what we're doing is we're allowing the user to create this input data set by uploading an input file. And you can see that if there's nothing, it's null, it returns a blank. So there's nothing to do. Once they upload an input file, the server is going to read that file and observe the event that an input file has indeed been uploaded. And then it's going to say, oh, okay, well, the first column by default is going to be the yvar, and then the update select input for the xvars is going to be left blank. It's just going to be a selection option of different column names. So that's how the information gets to the user, basically, once they upload the data. So all of that, again, episode 148, we went over. Some of the new stuff. Here we go. Line 193. The first thing that we need to do now is, because we're allowing the user to set up their own train and test set splits, we want a random allocation of our data based on the percentage that is specified by the user. So in order to do that, what we have in line 94 is we're going to use the sample function, which is going to generate a random sample from some vector of numbers. In this case, we're specifying that vector of numbers to be numbers 1 through the number of rows within the input data set. And the size of that is going to be the input train set, so the percentage that the user specifies on the input, multiplied by the number of rows in the input data set. And we take the ceiling so that we're just rounding up, and we don't have any like fractions or anything in there. It's just a very clear, it'll be a very clear number. And replacement is going to equal false. So if, let's say, at random, row number 5 is taken, we don't want to allow row number 5 to be taken again. So once it's out, it's out. And so that gives us row ID. So this is basically a reactive that every time the user changes that percentage of train set allocation, it's going to create a random sample of the row IDs. And because we now have row IDs, it makes it really easy to grab those rows and allocate them to the testing set or the training set when we fit our model. In this case, we're going to allocate them to the testing set because that's where we're going to do our predictions on. So we take the input data set. We're going to select whatever the user defined as their input Y variable, and we're going to call it the dependent variable. And then we're going to select all of the variables that they specify as their X variables. And the slice function in Tidyverse is how we basically tell the data set that we want these explicit rows. And in this case, because this is the test set, we want all rows that are not the train IDs. So we're doing minus train IDs, meaning we're going to get rid of those and we're going to only be left with the test set. Then we go and fit our model. This is exactly like we did last week. The only difference here is that instead of using the full data set, we're now going to take that data set and we're going to slice out the train ID. So now these are going to be the rows that got allocated based on the percentage that the user specified to the training set. So we're going to select that data. Again, dependent variable is the input Y variable. Independent variables are going to be the X vars, and we just fit the model. So we fit the model to that new little data set data frame that we created. Now that we've got a model built, we're going to just go ahead and show out the summary. So we're going to render it as a print. So that's what we saw when we looked at the output of our Shiny app at the start. Is it's basically just the standard summary that you get when you run this in base R. So we're going to summarize the fit for the user so they can see the model, see the coefficients, the residual standard error, the R squared, those kinds of things. We're going to make some predictions with that fit on the new data, which in this case is going to be our test set, which we allocated from the not train IDs specified by the user. So now we have a vector of predictions, and we can take those predictions and we can dump them into some plots. The first plot is going to be the out of sample mean absolute error. So we go ahead and we first calculate that as the average of the absolute difference between the dependent variable in our test set and whatever was predicted from our model for that dependent variable. And we just store that value in this handy little element that we're going to use for the title in the plot, which is out of sample mean absolute error is going to equal the mean absolute error that we just calculated. We're going to throw that into a histogram. The X label we need to not leave blank, but we need to change that to residuals. So the histogram, test set, yeah. And so this is going to be a histogram of the residuals, and the title for this is the mean absolute error on the out of sample data. And we just put the AB line at 0 because a 0 is basically an exact prediction. It got it 100% right. The other plot that we're going to make, just like last week, is going to be this plot of the actual versus the predicted values. So we take that test set, we drop the predictions in that we calculated up above, and then we're going to make a GG plot with the predictions on the x-axis and the dependent variable, the actual observations on the y-axis. We make a little point, so a little XY plot with that, and we drop in that AB line with an intercept of 0 and a slope of 1. So exact predictions will be lying directly on top of that line. Everything else is some sort of deviation from those exact predictions. And we just give it a clear title like predicted values versus actual values, and this is the out of sample data. Finally, just to finish up, again, last week we had one DT table, which was all the data. This week, we're just going to actually take that data and split it out. So we've got our input data file, and we're going to slice out just the train IDs, and we're going to give it a caption or title in data table, which is called train set. And then we're going to take the test set that we created up above, and we're going to drop that into a data table, and we're going to caption that as the test set. And that is the server for this highly interactive Shiny app, which allows the user to produce models and get outputs and get out of sample predictions.
There we go. So now we can click around again, and you can see now that you understand the logic behind this, how once we uploaded empty cars, we covered this last week, how the MPG got selected into outcome variable, The predictors were blank initially, but then we could go through and click on various other variables that we wanted to be including as predictive variables. We can now slide this up and down and see how it's now going to, every time now it's going to take 65% of the data, train on that. Again, a random 65%. So every time we move this, it will be different. So even
Yeah.
if
So
I
if
slide
you
this up and then slide
and
this
then go
back
back
down
to
to 65,
65%
it's
different.
a whole new set.
Yeah.
We can see how these two
Which I guess
plots are generated.
we could add an option for the user to set a seed or something like that, but
We could, but do we
yeah,
want to?
well,
Comment down
maybe
below
not.
if you want that.
Yeah, right.
And then we got our two other tabs here showing our training set and our test set and the values that were used for that. And that is how you construct a Shiny app where you use a model to predict. You can select the outcome variable, the predictor variables, as well as allocate a certain amount to training and to test to verify the quality of your model. And
Ooh.
so, with that, we're going to call episode 149 a wrap. Thank you all for joining us for 149 episodes. My name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, at tidy_explained is the handle for the screencast on Twitter. Of course, the easiest way to hit us up is on the YouTube channel. As we've said before, like and subscribe, comments down below. Always easy way to get in touch with us. We love doing the show. And if you feel like it's helped you, the Patreon page is open. We're always appreciative of anything that you'd like to give to support our work.
Thank you all so much. Keep on exploring your world.